The lost math that proves Jupiter is a giant alien machine. The math said the next window would open at 2:17 Universal Time Coordinated. At 2:16, the spectrum looked like snow. At 2:17, 3 tight peaks rose out of the noise, locked to prime intervals, then cut to black. The recorder flagged non-natural periodicity. 30 seconds later, the sky was quiet again. If those numbers hold, Jupiter isn't just weather and rock, it's engineered. The key came from a forgotten manuscript, Harmonic Engines, Integer Lattices, a map of where energy should pool inside a gas giant. Our chase starts with a lab anomaly, old Galileo data, and a researcher who vanished. To understand the blip that shouldn't exist, we go back. The manuscript that shouldn't exist. The notebook didn't belong in that basement room. It was misfiled under thermodynamics, wedged between a broken ring binder and a stack of mimeographed lecture notes. Acid brown paper, thread binding. The front leaf carried a neat, slanted hand. On harmonic engines, with notes on planetary resonance. No author, no date, but the paper watermark in ink chemistry would later peg it to the late 19th century. A graduate student named Mara pulled it because the spine looked wrong. She thought it might be an old lab ledger, good for archival credits, nothing more. 2 pages in, the handwriting turned from formal prose to dense mathematics. Integer ratios stacked in lattices, prime gaps marked in red pencil, spherical harmonics sketched like weather maps. In the margins, nodes energy minima, engine frame, and underlined twice, gas giants. The math shouldn't have existed in that form. Integer resonance lattices, the idea that stable energy patterns emerge at whole number ratios across spherical modes, are modern tools in seismology and plasma acoustics. Nested primes guiding sequence activation? That's cutting-edge coding theory. Yet the notebook treated both like a craft. Lay the lattice, count the primes, tune the shell. It proposed that within a layered fluid sphere, discrete harmony windows would concentrate energy into predictable nodes. Not theoretical elegance, engineering notes. Mara brought it to her advisor, expecting a polite nod. Instead, he closed the office blinds and read without speaking. The equations outlined a scaffold where spherical harmonics, the standing wave patterns that fit on a sphere, interlocked at integer ratios so clean the error terms canceled like teeth in a gear. The red pencil primes weren't numerology. They indexed which harmonic families could activate without beating each other into chaos. Then came a table labeled Jupiter, with radii expressed as fractions of an assumed planetary radius, and an angle set that matched the latitudes of major jet streams, decades before spacecraft ever mapped them. Why it matters is simple. If you can predict where energy prefers to collect in a turbulent sphere, you can shape the turbulence. The notebook implied planetary design, harmonic engines embedded in gas layers, using resonance to route energy the way pipes route water. The notes suggested control of storms and magnetic fields by exciting specific modes at prime-separated times, avoiding destructive interference and distributing energy efficiently. It was a blueprint, or it was a hoax so good it anticipated discoveries no one had made. Mara tested one claim the notebook called obvious. She overlaid the listed node radii on publicly available Jupiter density models. The rough matches were unsettling. Then she converted the prime step schedule, 2, 3, 5, 7, 11, into phase windows and checked old ground-based radio logs for bursts near those intervals when Jupiter's rotation put certain latitudes in view. Too many hits to dismiss as chance. Not perfect matches, but clustered. That's when the human cost began. Her advisor told her to slow down. "You don't publish this," he said, tapping the word engine as if it could bite. He offered safe projects, thermal convection models, feature tracking. She ignored him and drafted an abstract for a small conference, carefully avoiding the word engine, calling it resonant energy localization. 2 days later, her submission portal returned an error, withdrawn by author. She hadn't withdrawn it. Meanwhile, the notebook became a riddle. Some pages referenced Galileo, which, at first glance, meant the person. But the phrasing, Galileo confirms the high-order L equals 10 anomalies, suggested a dataset, not a Renaissance telescope. The modern Galileo spacecraft flew in the 1990s. The notebook predated it by a century, unless the notebook had been updated later by another hand. A different ink tone appeared in the margins on a few pages, the neat slanted hand interrupted by blockier annotations. Compare with GLLPWS, Juno SSW to verify. Someone had revisited the manuscript after the probes returned. So what was it? A hoax retrofitted with modern acronyms? A palimpsest where a living researcher used an antique notebook as cover? Or a decrypted blueprint from somewhere else, passed hand to hand and annotated across generations? Mara's curiosity pulled her deeper. The integer lattice wasn't a mere pattern, it was instruction. Start with the lowest spherical modes, the big, slow planet-sized oscillations. Fit them at ratios of simple integers like 2 to 3 to 5 to create a scaffold. Use primes to gate which layers receive energy at which times, so that no adjacent layer reinforces a destructive beat. The payoff: stable, long-lived vortices at known latitudes, synchronized jet streams, and an amplified magnetic dynamo without catastrophic turbulence spikes. Her mentor, trying again, walked her through the risks. Extraordinary claims, career-ending ridicule, the black hole of fringe forms. "You're smart," he said. "Don't set your life on fire." He wasn't wrong. But while he worried about reputations, Mara worried about consistency. The numbers in the notebook weren't vague. They predicted energy nodes at specific fractions of the radius and preferred longitudes tied to rotation harmonics. She pulled gravity field coefficients from Juno's public releases, J2, J4, J6, and saw minor anomalies near values the manuscript emphasized. Not proof, but a drumbeat. Then came the email. It looked routine, a request to consult on signal processing for planetary radio data. No signatures, just an institutional address and a dataset link. When she clicked, it requested two-factor authentication for a system she didn't have access to. 10 minutes later, her advisor called her into the hall. "Who did you tell?" he asked. He'd received the same message, then a follow-up. "Please disregard." She printed 3 chapters of the notebook and locked them in a campus safe. The rest she scanned to an air-gapped drive. The next morning, the basement room's keycard reader was taped over with a new notice. Collection temporarily closed for inventory. Inside, the shelf where she'd found the notebook was empty. While the ink was old, the numbers matched something modern. And somewhere, out past the campus lights, Jupiter turned, its storms circling on rails she could now describe. The signal in Jupiter's shadow. The first time the burst hit, Mara wasn't even in the control room. She was trying to coax a coffee out of a machine that ate dollar bills. In the lab, a narrowband receiver watched Jupiter's limb while the planet slid behind Earth's ionosphere sweet spot. The lost math gave a window, Prime stepping the clock, so they pointed a modest dish and let the recorder run. At 2:17, 3 knife-thin spikes rose exactly where the notebook said they would, then fell away like a hand lifted from piano strings. They didn't celebrate. They doubted the instrument. The lab had seen spurious spikes before: satellite bleed, terrestrial interference, even a microwave door that didn't seal. Mara and 2 postdocs reran the chain. The FFT pipeline, the notch filters, the local RFI map. Nothing obvious. The event straddled a predicted harmonic node window, a phase aligned with a prime-structured schedule, timed to Jupiter's rotation, so a latitude band the notebook emphasized grazed the line of sight. The spectrum looked clean. The metadata looked boring. That was the unsettling part. To keep their heads, they cross-checked public spacecraft data. Galileo's plasma wave subsystem recorded intermittent, structured radioactivity in the decametric range, often tied to Io's position, but tucked in those archives were odd sequences that didn't fit Io-driven modulation. Juno's waves instrument logged auroral hiss and bursty emissions with substructure that sometimes repeated. Mara pulled a slice of Galileo near one of the notebook's prime intervals and overlaid it with Juno's closest counterpart years later. The envelopes matched a little too well for comfort, peaks separated by intervals that mapped to the same prime steps the notebook indexed in red pencil. Skeptics had a straightforward case. Jupiter is loud. Plasma instabilities and cyclotron masers make radio noise with patterns that can mimic intention, and observational cherry-picking turns randomness into rhythm. If you watch long enough, any interval will look special. Good arguments, and nobody on Mara's team wanted to become a cautionary tale. But the lab anomaly wouldn't fit the usual boxes. The instrument auto-flagged non-natural periodicity, only when 3 independent criteria stacked: timing within a narrow tolerance, spectral coherence across adjacent bins, and a phase consistency that survived time window shifts. It had never fired all 3 on a Jupiter pass. They scheduled a midnight recalibration, the kind where you strip the system to bone. The dish pointed at empty sky. They injected test tones at known offsets, then pulled the clock from GPS, and ran an oven-controlled crystal oscillator to eliminate timing contamination. No spikes. They swung the dish across a geostationary belt to pick up known RFI carriers. The detection algorithm behaved. They waited. At 2:11, they returned to Jupiter and held the gain low to avoid front-end compression. The prime window approached. In Mara's notebook, hers, not the antique, a penciled line traced the seconds. At 2:17, the spectrum trembled, then the triplet stood up again, slightly shifted, same spacing. She didn't exhale until it was gone. Meanwhile, something else was happening across town. A friend at a different university had agreed to run a parallel observation as a sanity check. No shared clocks, no shared software. Their system wasn't as sensitive, but the time stamps would tell a story. The next morning, an email with no subject arrived. We saw it too. One peak only. Same second. Their data had lower resolution, and the other two spikes were buried in noise. But the coincidence tightened the loop. What nobody knew at the time was that Galileo's team had once dismissed a sequence like this as ground system artifact. A footnote in a technical memo mentioned a repeating triad near the limb during a pass when Io's influence should have been minimal. It was flagged and filed. Mara tracked down the memo through an old FTP mirror because the main archive didn't index that page. The triad spacing mapped, again, to the prime intervals in the manuscript. If periodicity is intentional, you aren't listening to weather, you're hearing a clock. The stakes snapped into focus. A clock implies state implies a system, and a system implies behavior that could wake, idle, and respond. That's a different kind of risk than bad optics at a conference. You don't accidentally ring a bell like that. So they tried to break the case. They mapped the bursts against known decametric modulation by Io and found the timing sat off the classic IOA and IOB sources. They compared to Earth-based RFI catalogs and saw no carriers near the triplet bins during those seconds. They folded days of Jovian rotation to see if the pattern repeated at a simple rotation harmonic. It didn't. It appeared only in the prime-spaced windows the notebook predicted. That cut both ways. It strengthened the manuscript's claim, but it also raised the danger of confirmation bias. A quiet voice in the room kept repeating, "Prove the negative." Mara scheduled a blind test. She randomized timestamps from Blank Sky and from Jupiter, shuffled the labels, and asked a colleague who didn't know the project to run the detector. The algorithm flagged only the true windows near Jupiter, not the decoys. Then they removed the prime window constraint entirely and scanned a month of data. No triplets. The lab anomaly was stubborn. During one long night, as clouds rolled over the dish and wind pressed the dome seams, the team debated the skeptic's strongest line. Non-natural periodicity is a loaded phrase. Nature loves patterns, but the lab's own metric didn't declare intelligence. It declared a pattern that didn't match their current catalogs of natural drivers. That was enough to justify a deeper look and not enough to hang a career on. Still, the clock metaphor stuck. It kept time across instruments and years. It ticked in a way noise didn't. By the third detection, the coffee machine worked. A small mercy. The triplets had slight phase drifts, predictable if a rotating shell was involved. The drifts matched the manuscript's note about precession of active shells, scribbled in a different ink. The pattern wasn't random, it was a clock. And if there was a clock, something somewhere cared about the hour. Harmonic Architecture 101. To understand the clock, we need the architecture that could keep time inside a storm. Start with resonance scaffolding. In any sphere, waves can stand in patterns called spherical harmonics. Think of them as ripples that wrap a globe, each with an index, L for the number of nodal bands, M for how they twist around longitude. Most combinations interfere and die. But when you stack a few at simple integer ratios, 2 to 3, 3 to 5, their energy reinforces and locks, creating long-lived structures. The manuscript's integer lattice took that basic physics and made it prescriptive. It mapped a grid of allowed modes where L and M pairs sat on integer rails that minimized crosstalk. Then it layered time. Those red primes weren't decoration. They sequenced when each mode could accept energy. A prime step schedule, 2, 3, 5, 7, 11, staggered injections so no two adjacent shells beat against each other. You get clean buildup instead of turbulence. Spherical harmonics meeting prime-based sequencing sounds esoteric, but it's an engineer's trick. Integer ratios reduce error accumulation. Primes prevent synchronized collisions. The notebook argued that a gas giant's layered convection could be coaxed into quasi-stable lanes if you excite the right modes in the right order. That's harmonic control, not brute force. You don't fight the storm, you whisper to it at frequencies it can't ignore. Now remember what Juno and ground-based imaging teach. Jupiter's atmosphere is banded, east-west jets, stacked like conveyor belts. In the lattice, those bands coincide with latitudinal nodes where certain L modes concentrate shear. Antinodes, where the standing waves bulge with energy, line up with the long-lived vortices. The Great Red Spot sits near one such antinode latitude. The Manuscript's table, angles and radii penciled with care, predicted not just bands but preferred longitudes, where intersecting modes create cradles for vortices to persist. Visualize it, nested shells of gas, each carrying a dominant mode. At certain depths, metallic hydrogen forms a conductive sea. Above it, molecular hydrogen behaves like a compressible fluid. The lattice runs through both. Energy routing happens along the nodes like tracks, shunting momentum laterally before it can blow vertically into chaos. Antinodes act like capacitors, soaking energy and releasing it on schedule. That schedule is the prime sequence, a metronome that opens and closes windows to shuffle power without collision. Mara's mentor called it beautiful and dangerous. In a quiet hallway he said, "You don't publish this." He'd seen careers shredded by symmetry that looked too neat. He warned that nature rarely respects our clean grids. But even he couldn't ignore how the lattice explained otherwise stubborn features. Jets that refuse to diffusive away, vortices that last centuries, auroral power that varies in steps. Take the magnetic field. Jupiter's dynamo lives in that deep metallic layer, where charged flows cut magnetic lines and generate the magnetosphere. If the lattice modulates flows there by gating torsional oscillations, those slow twist waves that spin bands faster and slower, you get controlled variations in field strength. The notebook treated torsional waves as the machine's belts, moving angular momentum between shells on a prime cadence. Storms above ride those belts like timing cams on an engine. Engine language isn't just metaphor in the manuscript. It spoke of valving layers, couplers, and quench intervals. In plain physics, those could be stratification boundaries where density jumps reflect waves, shear zones where momentum transfers, and radiative layers where heat can dump. The prime windows would be the quench intervals, moments when the system breathes, letting pressure equalize without feeding instability. Meanwhile, something else clicks. Spherical harmonics don't care about liquids versus plasmas. They care about geometry and boundary conditions. That's why the same math shows up in starquakes, Earth's free oscillations after big earthquakes, and even room acoustics. The notebook exploited that universality. It unified acoustic mechanical control across phases of matter by choosing integer families that survive damping. That's why ancient math would aim this way. If you didn't have transistors, you'd use resonance and ratio. Stone circles that pick up whispering gallery modes, temple chambers that focus chant frequencies. It's the same instinct, scaled to a planet. Let's ground it in one clean scene. Mara took a standard spherical harmonic expansion used in weather models, YLM functions, and restricted the basis to integers the manuscript allowed. When she ran a toy simulation, jets aligned, and rogue vortices damped quicker than in the full basis. When she loosened the integers, chaos returned. Not proof, but a sign. Constraint creates order. The impact of accepting this architecture is heavy. If a resonance scaffold exists, storms can be modulated like turbines in a dam. You can bleed momentum from one latitude to another, steer heat from deep layers toward selected outlets, and throttle the magnetic field without frying the system. Maintenance signatures would look like sudden calm where chaos should reign, stepwise shifts in jet speed, and radio emissions that arrive on a timetable. We've brushed against all three. So if there's a clock, there must be a machine. A machine doesn't have to be gears and pistons. It can be geometry and timing. The manuscript drew the geometry. The prime sequence kept the time. Jupiter provided the mass and the medium. And out at 2:17 universal time coordinated, something kept the beat. Storms that behave like engines. Start with the Great Red Spot. We call it a storm because that's the box we have, but its behavior refuses the label. Centuries-long persistence, phase-locked drift rates, energy balance that doesn't crash despite constant shear. In the lattice view, it isn't a storm. It's a regulated vortex parked in an antinode cradle. The notebook predicted cradles where intersecting modes create low-loss basins. That's where a vortex can feed without shredding itself. Observed longevity versus expected decay is the first tell. Turbulent vortices of that scale should bleed energy into surrounding jets and die on timescales of decades. Yet the spot holds on, shrinking and breathing but not failing. Maintenance signatures look like abrupt calm at the periphery, sudden reductions in nearby eddies, and stepwise changes in drift. Juno's long baseline imaging shows intervals when adjacent storm fields go quiet together, like power to a neighborhood temporarily throttled, then restored. Compare Saturn's North Pole hexagon. Different planet, same family of physics. A hexagon is a standing wave carved into a jet, an M=6 mode locked to latitude. It's a geometric governor, not a meteorological accident. The manuscript used Saturn's hexagon as a comparative design hint, proof that planetary flows settle into discrete resonant shapes when boundary conditions permit. If you can nail a hexagon on Saturn, you can lock vortices on Jupiter, if you've got a scaffold. Juno's gravity passes add weight. High-order gravity coefficients capture mass redistribution in the upper layers. When observers mapped anomalies, some features traced lines not quite explained by thermal winds alone. Lay the manuscript's predicted node lines over those maps, latitudes and longitudes where L and M families intersect, and a few gravity wiggles ride those rails. Not a perfect overlay, but enough to make you pause. Density follows structure, structure follows resonance. There's a night in the lab that sticks with me. Mara filtered a month of time-lapse data of Jupiter's belt jet boundaries. She wasn't looking at color, she was tracking vorticity, how fast parcels spun. Every few days, she saw a maintenance dip, a synchronized drop in spin in two adjacent zones, like a pump easing pressure. The dips appeared near the prime windows the manuscript circled. They'd last hours, then the chaos returned. Weather? Maybe. But the rhythm matched the clock. Here's where skeptics press, and they should. Jets can couple through wave-mean flow interactions, and energy can move in bursts without anyone flipping a switch. But the lattice gives a clean mechanism. Torsional oscillations trigger a quench interval, moving angular momentum along allowed modes while temporarily damping cross-mode chatter. From above, that reads as storms settling down in sync. From within, it's belts slipping, then gripping, a timing cam doing its job. The great red spot's recent behavior fits. It's smaller than it was a century ago, shed flakes at the edges, then stabilized. In a free system, you'd expect a monotonic death. In a regulated one, you get adjustments. The cradle geometry changes as deep modes shift, so the vortex reshapes but remains caged. Spectral analyses of its drift reveal quantized changes in longitudinal speed, exactly what a stepwise control schedule would imprint. Meanwhile, something else is odd. The chains of smaller ovals that flank the spot, white and brown, sometimes align into marching formations, then dephase. In the node view, those are subordinate rotors slave to a master mode. They take energy when the window opens and release it back when it closes. Microgrids tied to the main grid. During one sequence, 3 ovals faded almost simultaneously, as if starved. Hours later, the belt to the north spun up. Energy moved. That's an engine signature, not a squall. We should talk boundary layers. Between ammonia ice tops and deeper water clouds sits a radiative transition where heat leaks efficiently. The manuscript labeled it a valving layer. Waves reflecting off that boundary can either reinforce surface storms or shunt energy downward. If you time reflections with prime spacing, you avoid resonance catastrophes and keep the machine quiet. Juno's microwave radiometer peaks below the clouds and sees plumes and voids in stacked tiers. Those stacks pair neatly with the valving concept. Layers that open, layers that hold. And then there's lightning. Jovian megaflashes cluster near certain latitudes and sometimes pulse in trains. On a control schedule, lightning isn't just weather, it's a bleed, a release mechanism when a shell takes on too much charge or pressure. Trains near predicted windows hint that the system vents on time. After trains, storms often relax. It's messy, but the rhythm peeks through. If this is flow control, we should see coupling to the magnetosphere. We do. Auroral power sometimes ticks up when belts below settle down. It's counterintuitive, calm above, roar at the poles, but elegant if the machine shunts momentum into field-aligned currents during quench intervals. Juno caught bursts in the polar Aurora coincident with atmospheric lulls equatorward. You can read that as noise, or as power routing. So what do we call a planet whose storms behave like this? An engine is a loaded word, but it fits the function. Vortices are regulated rotors, jets are timing belts, boundary layers are valves, and maintenance shows up as quiet where chaos should be. The machine doesn't need metal, it needs timing, geometry, and mass. Clocks and flows are only half the story. Engines need power, and Jupiter, louder than it should be, runs hot. Where's that power coming from? The power source buried in the roar. Jupiter leaks heat. Not a trickle, an excess. It emits more energy than it receives from the sun. A steady glow from within that shouldn't be so generous for a world that old. Standard models blame leftover formation heat and slow contraction, Kelvin, Helmholtz cooling, but the rate is stubborn. In the lattice view, excess isn't a problem, it's a budget. A machine that modulates flows needs headroom, a reserve to push and pull without starving itself. The manuscript flagged torsional oscillations as the belt drives, broad, planet-girdling twist waves that move angular momentum between latitudes. Observers have seen hints of those oscillations on Jupiter, belts speeding up, then slowing in patterns that sweep across longitudes. If those twist waves couple to deeper layers, they can tap rotational energy and convert it into heat and electromagnetic work. Think of it as a flywheel. The planet's spin is the store, torsional waves are the gears. Drop deeper, into pressure that turns hydrogen metallic. That layer isn't a simple conductor. Under Jovian conditions, it approaches superconducting behavior in some models. Low resistance, high carrier density, extraordinary mobility. The notebook treated it as a superconductor lattice, not in the solid-state sense, but as a contiguous medium where magnetic fields and flows can lock without bleeding energy. In that sea, alphane waves, magnetized ripples, can run with minimal dissipation, ferrying energy from the equatorial engines to the polar caps. Here's the trick the notebook kept circling. Route momentum changes through that metallic layer on prime-timed intervals, and you get controlled surges in the magnetosphere. The magnetosphere is Jupiter's halo, an enormous bubble laced with current sheets and flux tubes. Io threads one of those tubes, lighting radio sources like a violin bow on a string. But the system roars even when Io's out of tune. The lattice offers a driver, prime-gated torsional pulses that pump the field, fill the halo, and discharge at the poles. Lightning seals the argument with teeth. On Jupiter, megaflashes aren't scattered evenly. They cluster, sometimes marching in cadence. Storm towers loft water and ammonia, charge separates, and bolts crack down. But in the lab's timelines, some of the most violent trains of flashes lined up with predicted resonance beats. That's what you'd expect if lightning doubles as a safety valve. When a shell absorbs a timed push, pressure, and charge spike. If the quench interval is late, the system bleeds, fast, bright, and loud. After trains, the belts often realign, as if relief restored the schedule. One night, a polar observatory watched the Aurora, while Mara's team kept ears on the radio. The clock said a window was due. Minutes before the mark, the oval dimmed. At the prime second, a spike hit the UV imagers and their receiver together. It looked like an auroral switch thrown on cue, an intake pull snapping open. The magnetosphere doesn't usually behave like a streetlight, yet it blinked, and the radio hiss sharpened into a ridge with the right spacing. The lab's non-natural periodicity flag tripped. Everyone stared at the silent screen after the spike, hearing only fans. Skeptics counter with a fair point. Jupiter's internal heat and radio outbursts are well explained by known physics, convection, dynamos, cyclotron masers. True, the manuscript never denied that. It used those same mechanisms and added timing and topology. A dam doesn't invent water, it manages flow. Here, torsional oscillations are valves, metallic hydrogen is conduit, lightning is a pressure gauge, and the magnetosphere is the transmission line broadcasting load shifts as Aurora and radio. The energy budget closes if you let rotation pay the bill. Jupiter's spin is furious, about 10 hours per turn. Torsional waves can siphon a whisper of that angular momentum and turn it into heat and field work without appreciably slowing the planet on human timescales. Over eons, that whisper adds up. Measured drifts in jet speeds, tiny stepwise, become signatures of withdrawals. The heat excess becomes interest, energy skimmed and redeposited to keep the scaffold humming. Now, the metallic layer matters for another reason, coherence. In a resistive fluid, timing smears out. In a highly conductive medium, waves preserve phase longer. The prime windows need phase integrity across shells, or the schedule jams. The manuscript's margin notes, later ink, called it phase hygiene. Juno's in situ fields recorded intervals when alpha-venic fluctuations became unusually monochromatic, narrow-banded waves sliding along field lines like rails. Those intervals often preceded auroral brightenings and followed belt quench dips. That's a protocol peeking through. The magnetosphere, busy as it is, acts like a halo antenna. Field-aligned currents climb out of the metallic sea, arc through space, and land at the poles. When the lattice opens a window, current surges with a distinct spectral fingerprint, what the lab started calling a call sign. That's the halo doing double duty, carrying power and announcing state. The manuscript hinted, transmission halo, state pulse, maintenance lock. It's blunt, almost crude, and exactly what you'd build if your machine spans a planet. Each machine has a protocol, handshakes, heartbeats, resets. Did we glimpse one? The 217 triplet answered with timing, not words. The Aurora spike hit the prime second like a receipt stamp. Lightning trains synchronized with beats like pressure relief valves opening and closing. Torsional bands shifted speed and step, as if belts tightened. The roar had structure, and buried in it was a power source that wasn't a mystery after all. It was rotation, routed through resonance into heat, light, and field. The clock ticks, the engine breathes, and the halo sings its state to anyone listening. The prime interval protocol. The notebook didn't just sketch lattices, it laid out a schedule. Prime windows, the margin said, underlined twice. Activation intervals spaced by 2, 3, 5, 7, 11, never multiples, so no harmonic stack and blow out the scaffold. In practice, that meant small, precise opening times when energy could move between shells without spawning chaos. If you're running a planetary machine, you want those windows disciplined, rare, and unmistakable. Mara mapped the red pencil primes onto universal time, using Jupiter's rotation as the carrier. When a window arrived, she expected nothing dramatic, maybe a shift in vorticity, maybe an auroral nibble. Instead, she got triplet bursts in the radio, and timed spikes in UV. Not every window lit up, several slid past with only noise. That was the first clue. The protocol wasn't a chime on every hour. It was selective, like a maintenance slot that only opens when a subsystem requests it. Cross-checks hardened the edges. She tagged auroral brightenings recorded by Juno against the prime schedule. More than chance aligned, a subset of brightenings hugged the predicted seconds, and when they missed, the delay clustered at offsets corresponding to known solar wind compressions. The protocol seemed to flex around external stress, keeping phase when it could, slipping when it had to, then snapping back on the next prime. A metronome that listens. Then came the missed window, the one that changed the room's temperature. The schedule called for a 7-step opening at 3:41 Universal Time Coordinated. They were live. Jupiter was in view. Instruments were clean. At 3:41 nothing, not even a whisper. 38 seconds later, a broad, low-Q swell rolled through, wrong spacing, sloppy phase. The flag stayed dark. To a skeptic, that was a relief, randomness restored. To Mara, it looked like a system skipping a step under duress, bleeding off in a safe mode, rather than hitting a locked interval out of alignment. The manuscript had a scribble for that. Quench-only mode, skip to next prime. The stakes sharpened. If the protocol adapts, it might be reactive to the sun, to Io, or to us. The team split. One camp pushed to publish now, lock in priority, invite replication, survive the fallout. The other camp said no. Going loud risks drowning the signal in noise, the wrong kind, the human kind. There was also a quieter argument, the one nobody wanted to voice. If you announce that you found a clock, someone with bigger antennas and deeper pockets will take it away from you, or take it away from everyone. That's when the off-book warning arrived. Mara got a call from a number that resolved to a shared university switchboard. The voice was calm, older, and didn't introduce himself. He referenced a figure in her draft, a timing diagram she'd only shared in a closed folder, and said, "You're sitting on a protocol. Don't stimulate it." Then he hung up. Minutes later, her access log showed the draft had been opened by an account she didn't recognize, then closed. They argued late into the night. Protocol implies rules, and rules imply consequences. If the prime windows are maintenance slots, prodding them could force a reallocation, maybe harmless, maybe not. The lab wrote a rule on the whiteboard: listen only. No beacons, no chirps. Passive until patterns stabilize. That became policy, and still the room felt watched. Meanwhile, alignment with radio bursts kept tightening. The lab pulled decametric archives from observatories that had logged Jupiter for decades. They weren't hunting any triplet. They were looking for the specific prime spacing signature with preserved phase across 2 or more events. The hits were scarce but clean. In several cases, a missed window was followed by 2 shorter, tighter bursts at the next prime, like catching up on skipped work. The manuscript called that a double valve, a make-good. One microstory anchored the abstract math in human time. At 2 a.m., after a failed recalibration locked the dish at half gain, Mara decided to keep listening rather than shut down. The window approached. Against the hiss, a single narrow line rose, not a triplet, just the center tone. The flag didn't fire, the algorithm needed 3. She logged it anyway. 8 minutes later, 2 more lines appeared, spaced exactly within tolerance. The software backfilled the detection and lit the board. Maintenance didn't arrive on schedule, it arrived in pieces. The protocol had flexed, then locked. Skeptics pressed their strongest case. Prime spacings sound like numerology. Why not Fibonacci? Why not random intervals that just look prime under selection bias? The answer lived in interference. Primes are immune to shared factors, in a layered system that prevents resonant collisions between adjacent shells. When Mara modeled Fibonacci spacing, shells with near-commensurate periods beat and amplified ugly sidebands. Prime spacing minimized those beats. The model wasn't nature, but it explained the why behind the when. Publishing would put that why into the world. Going dark would buy time to test. The team compromised. They prepared a data package without interpretation, timestamps, spectra, instrument configs, and queued it for release to a small circle under embargo. Before they hit send, the student, the one who lived in the numbers more than the meetings, spoke up. If it adapts, someone is listening. The room went silent. You can debate intention forever. You can't debate behavior. Adaptive timing is behavior. They held the package for one more window. The clock ticked, the Aurora lifted, and the radio sang in prime. The protocol held, and a new question arrived with it. If the schedule can flex, who or what does it flex for? The Whisper Network and the Vanishing. It started small, an email thread that wouldn't stay put. Mara sent a zipped spectrum, triplet marked, timestamps clean, to 3 trusted colleagues. 2 replied. The third never saw it. When she resent, the thread showed as delivered, then hours later returned to her drafts with a new label, unsent. On the lab server, the access log listed a phantom open from an IP reserved for administration. Nobody would admit to touching it. A day later, a dataset disappeared mid-analysis. They were pulling decametric archives from a public mirror, old but reliable, when an error froze the transfer. The folder they'd been drilling into blinked out of the index while their script was still reading it. Refresh, nothing. 10 minutes later, the parent directory reappeared, minus the subfolder with the triad-like sequences. The mirror's maintainer wrote back 3 words. We didn't move anything. Then the conference slot vanished. They'd secured a short talk at a mid-tier planetary meeting, safe enough to float a methods-only presentation. The agenda went live. Their title sat between magnetotail turbulence and ionospheric coupling. 2 days before travel, a revised schedule removed their block and replaced it with break. No explanation. Their confirmation email linked to a 404 page. When Mara called, the coordinator apologized, said the room needed reconfiguration, and offered a poster slot in a hallway no one visits. Pressure shifted after a late-night message from an unfamiliar address. Retired Deep Space Comms analyst, 30 years in deep antennas, wanted to talk off record. He'd seen their timings, he said, and they rhymed with a class of anomalies his team used to call radio ghosts, repeating primish spacings that cropped up near planetary limbs and got written off as processing artifacts. We scrubbed them because we couldn't label them, he said. I think you're labeling them. They met in a parking garage because he insisted. Level 3, far corner, engines on. He wore the look of someone who has told himself he's being careful for so long it feels normal. He handed Mara a thumb drive and a folded grocery receipt, and warned that some of what he'd clipped wasn't meant to be stitched together. On the drive, he said, were internal memos, antenna logs, and his own overlay files, node maps, latitudes, longitudes, and times that tracked across decades. You'll see the primes, he said. You'll also see when they don't show and why. They didn't get a second meeting. 2 days later, he missed their follow-up call. His number rang to a generic voicemail. One message arrived an hour after, static for 4 seconds, a breath, then his voice low, tight. You're not the first to find the clock. Keep your hands off the glass. The line cut. No caller ID, no callback. Meanwhile, the whisper network thickened. A friend at an agency lab, whose name never entered text, hinted that a Jupiter radio campaign had been paused, pending external coordination. Another contact said their request for legacy Voyager waveforms returned, temporarily restricted for quality review. That phrase didn't exist last month. When Mara tried to download a Galileo technical appendix that mentioned a triad near the limb, the link redirected to a homepage. Wayback saved it, but the live page died. Inside the team, nerves frayed. Someone had inserted a please disregard into an email sent from Mara's account. Tone wrong, punctuation wrong, but enough to confuse a collaborator into deleting his copy of their spectra. The lab's admin swore their server hadn't been compromised. Still, they pulled their project offline and moved files to air-gapped drives. The whiteboard rule, listen only, got a second line, say less. The drive from the garage held more than nostalgia. The Analysts overlays stitched early radio logs to prime windows and layered in solar wind data. When solar pressure spiked, the prime timings wobbled, then relocked, just like Mara had seen. He'd annotated gaps with short notes: station down, antenna off axis, budget cut, classified time. Between those, the primes beat on. He'd also marked ghost nights, when a triad appeared not at Jupiter, but near Earth's polar paths. Reflections of a protocol bouncing through our own magnetosphere. The implication was ugly. What looks like noise when you face the wrong way is a node map when you face the right one. The voicemail gnawed. Keep your hands off the glass. The phrase felt like it had history, as if others had pressed their faces there and left smears. In the lab, they played back the Analysts' clips, old antennas coughing up narrow tones no one had believed. A few matched the triad spacing with intolerance. A few didn't, but reinforced at double primes, as if a different layer was scheduling the work. Then the vanishing went personal. Mara's university ID threw a card reader error at the archive door, the same basement room where she'd found the notebook. The librarian shrugged, said the system was glitching, and let her in by key. The shelf where the notebook had been, reboxed, relabeled, pushed into conservation. When she asked to view the box, the accession number returned in transit. Transit to where didn't show. The team took stock. Emails were slippery. Data moved under their feet. A man who had seen this before slipped into noise. The drive he left behind mapped nodes across centuries, and the maps didn't care about careers. They cared about timing. If the protocol adapts, someone is listening. If someone's listening, someone knows when you speak. The drive held a key, node maps across centuries. And if those maps were right, the next prime window would open with or without them. Node maps through history. The thumb drive wasn't organized. It was a life's worth of scraps. Mara started with the earliest radio logs, amateur observatories from the 1920s and 30s, when crystal sets and home-built loops listened to the sky at night. The analyst had cleaned them, OCR'd the penciled notes, and overlaid the prime windows calculated backward using Jupiter's rotation. A few notations felt like throwaways, strange ticking 3 beats. But the time sat inside predicted windows with an accuracy that made her sit up. Primitive gear, yes, but the rhythm peered through. Mid-century institutional logs sharpened the picture. Naval arrays tracking ionospheric propagation tagged unresolved decametric bursts when Jupiter was grazing the horizon. The analyst's overlay painted those bursts with prime colors, 2, 3, 5, mapped to windows he'd reconstructed from ephemerides. Some nights showed nothing, others stacked neatly. Where the pattern broke, his notes pointed to solar storms or local blackout policies. Pattern integrity rose when the sun calmed, dipped when the wind screamed. Deviations weren't random, they matched solar cycle interference. Then came Voyager. In 1979, both spacecraft crossed the Jovian system and heard a planet shouting, "Damn emissions, hiss, arcs tied to Io." Buried in the torrent were short, triad-like sequences near the limb that mission scientists footnoted as artifacts. The analyst extracted those seconds and warped them into the manuscript's frame. Spacing normalized, phase compared. A handful clicked, too few to publish in their day, too odd to waste time on when the obvious science was gold. He labeled them handshake pings, a term his bosses would never have approved. To him, they looked like a check-in, clock ticks arranged to confirm alignment. One entry from 1979 had a tag that didn't fit until Mara cross-referenced it. a blip timed to the same minute as an Earth-side power grid cascade. Not a blackout, more like a phase correction ripple that walked through the network. Utilities recorded it as a nuisance event during a solar wind compression. The overlay put a Jovian triad within seconds of the grid's first correction. Coincidence? Maybe. But the analyst had collected 6 other instances across decades where small grid events clustered near predicted windows. He didn't shout causation, he wrote note proximity. Mara circled it and wrote if linked nudge. Early radio observatories, Jicamarca, Nanke, Arecibo, appeared in the file as stamps on a passport. The analyst had clipped public logs, staff memos, even a weather note scribbled by a tired technician. Jup. Window damn clouds got the tones anyway. The tones were weak, but their separation landed on the prime rails. On days when the sun was busy, the tones slipped, then relocked at the next window, like the protocol yielding to the solar driver before snapping back. The chilling inference wasn't that Jupiter argued with the sun, it listened. The machine knows the sun because its scaffold lives inside a star's weather. Mara layered in Galileo's plasma wave subsystem with regret. It should have been easy. The analyst's copy, sourced who knows where, flagged intervals that the official archive buried under engineering. The triads rode right at the limb during past geometry that minimized Io's influence. Juno's waves data, a generation later, showed the same habit. Not every window, but enough. Across 40 years, the node maps held their personality. They weren't perfect clocks. They were resilient ones, swayed by solar tides, tugged by Io, then corrected by a deeper metronome. He'd cataloged radio ghosts that weren't Jovian at all. Nights when polar receivers caught narrowband hisses inside designated radio quiet zones. The hisses had slope and drift that matched Earth's field-aligned currents in substorm recovery. Overlay the prime windows and a fraction lined up, as if maintenance pulses traversed our own magnetosphere on their way elsewhere, leaving fingerprints in auroral kilometric emissions. The analyst wrote, Echo? Outside. Mara underlined it, then looked at the ceiling for a long time. What nobody knew at the time, the part that made the room cold, was how far back the pattern could be stretched without breaking. The analyst's last section tried to push into pre-radio history. He included Auroral Diaries, Scandinavia, 1770s, East Asia, 1859's Carrington Storm, scattered ship logs with entries like curtain lights brightened thrice. He didn't claim proof. He sketched the prime windows backward and asked if the triple brightenings lined up. Sometimes they did. Sometimes they didn't. Solar fury dominated those eras. Still, the impulse was there. Map nodes through time until the thread snaps. The drive's power wasn't a single smoking gun, it was accumulation. Early logs aligned with predicted prime windows more often than randomness would prefer. Voyager's anomalies read like handshake pings when translated into the Lattices grammar. A 1979 blip sat uncomfortably close to a grid correction ripple on Earth. Deviations tracked the solar cycle's anger. And through it all, the inference grew teeth. The machine doesn't just survive the sun, it couples to it. If it talks to the sun, what's the message? The Sun-Jupiter coupling. To see what the machine is talking to, look upstream. Jupiter doesn't sit alone. It's wired to the sun by invisible ropes. Flux ropes, magnetic tubes of current, link the two. You can watch them in footprints, bright, fixed auroral spots where Io's flux tube slams into Jupiter's poles, and fainter siblings that wink in and out as the solar wind breathes. Those footprints aren't just pretty. They're terminals, places where field-aligned currents close circuits between the deep metallic ocean and space. Prime windows nested inside solar rotation harmonics make the coupling legible. The sun spins in roughly 27 days at the equator, slower near the poles. Its rotation modulates the wind, carving recurring pressure pulses that hit Jupiter like a tide. The manuscript schedule, those prime intervals riding a 10-hour Jovian clock, sits inside the solar beat like a gear within a gear. When the solar wind compresses the magnetosphere, the windows slip. When it eases, the schedule relocks. That's not random resilience. It's phase control with a bigger metronome in mind. Energy budgeting flips a common assumption. We think of Jupiter as a consumer, soaking up sunlight, leaking heat. But the coupling suggests it's a regulator. It stores and releases momentum into magnetic channels to buffer solar swings. During solar lulls, the lattice moves energy outward, fattening the magnetodisk, feeding alphenic waves that ride to the poles and glow as Aurora. During solar punches, it tightens, quench intervals deepen, belts grip, and power routes inward to keep the scaffold from ringing apart. The net effect is a thermostat, not for temperature alone, but for dynamic stress across the system. One microstory made that abstract budget feel like cause and effect. A coronagraph caught a modest coronal mass ejection leaving the sun. Slow, ragged, nothing headline-worthy. Days later, the solar wind reached Jupiter. In telescopes, the polar oval dimmed ahead of impact, as if bracing. At the prime second inside the predicted compression window, the Aurora flashed sharp and narrow, then settled into a steady glow. Minutes after, our receiver logged a triplet with perfect spacing. The timing chain from Sun to Jupiter to our dish clicked. If you drew a straight line through those events, it spelled acknowledged. Implication flows from that click, a solar system thermostat. The machine's job may be to hold the middle, keep storms and fields in ranges that don't tear the architecture. Do that long enough, and downstream planets benefit. Earth's magnetosphere flexes to the Sun's moods, but it shares the heliosphere with Jupiter's giant halo. When Jupiter's magnetosphere absorbs and shapes solar wind power, it tweaks the space whether we swim in. A gentle nudge, not a leash, but persistent nudges add up. Stakes get very real here. Tamper with Jupiter, and you touch the Sun's conversation with the planets. If the lattice mistimes a quench, you don't just rattle a storm, you misroute current along flux tubes that anchor in the solar wind. A bad shove could amplify a substorm, shift auroral power, or desynchronize belts that keep the dynamo quiet. On human scales, that reads as noisy magnetospheres, stressed satellites, jumpier ionospheres. On longer scales, you drift from a tuned system toward a loud one. Skeptics ask the right question. How do you separate cause from coincidence when the Sun drives almost everything? We did it by exploiting misfit moments. When the solar wind predicted a strong response, but the timing went soft, the machine's schedule often slipped in kind, missed prime, then a double valve later. When the wind was quiet, the primes hit clean. That conditional behavior is the fingerprint. Purely driven systems don't hold their own beat when the drummer rests. Meanwhile, flux rope footprints acted like check lights. I/O spot brightened on schedule, but during prime windows that targeted deep shells, secondary spots, non-I/O footprints, flared briefly, as if other circuits came online. Juno clocked those bursts alongside narrowband waves sliding down field lines, phase-stable enough to act as carriers. The notebook would call them talkers, channels for state pulses. We saw them as receipts, a system telling its power source, window opened, work done. There's a human hesitation threaded through all of this. If Jupiter moderates the Sun's moods, it has a say in the weather of space, and by extension, the rhythms of technology and life that depend on it. The question stops being academic when the schedule lines up with the infrastructure we built under that sky. Which brings us to the biggest question: who built it? Builders, timelines, and motives. Three theories lived on the whiteboard, underlined in different colors like suspects in a case file. First, a progenitor civilization, builders older than our myths, engineering with resonance because it scales. Second, machine ecology, no singular builder at all, but self-propagating systems seeding harmonic scaffolds where conditions allow. Third, warning buoy, Jupiter as a lighthouse, broadcasting a state to anything that can read primes and understand the clock. Progenitors sound like wishful thinking until you look at the math echoes humans left. Plimpton 322, Old Babylonian tablet, lists Pythagorean triples in a ratiogrammar 2,000 years before Pythagoras. The Sulba Sutras lay out altered geometries with integer constraints and diagonal rules. Megalithic structures embed ratios that ring, not just stand. None of that proves alien hands. It shows that long before calculus, engineers reached for integers and resonance because they're stable across scale. If someone had time and motive, they could carry those instincts into planets. Machine ecology wears a colder face. In that frame, harmonic engines aren't artifacts, they're organisms, resonant control systems that arise where conductive seas rotate under stratified shells. Seed conditions let feedback prune chaos, and the survivor is a scaffold that protects its medium. You don't need a mind, just selection on cosmic timescales. The notebook reads too intentional for pure emergence, but some of its notes, self-correcting, quench-only mode, lean toward ecology. The buoy theory is the most uncomfortable. A device that keeps time with primes is easy to recognize across cultures and species. You don't share language, you share number. A prime-timed halo that couples to the sun would be visible to any civilization with radio ears. If it's a buoy, it could be a beacon, occupied system here, or a quarantine marker. Do not disturb, stability managed. Motive matters. Intent changes whether you see a caretaker or a cage. Timelines push against comfort. Jupiter's age is deep time, 4.5 billion years. If the lattice rides internal physics, the scaffold could have been established when the metallic sea first cohered. Juno's gravity and field data imply an evolved interior, not a newborn. If you were a builder, you'd tune during formation, then let the protocol maintain. Human fingerprints only appear in the last blink. Our radio century sits like a hair on a mountain. Mara stared at the chalk smears and found herself circling back to echoes in human mathematics, not as evidence, but as motive clues. People who didn't share language still shared ratio. They built chambers that sing and stones that align to celestial rhythms. That's not proof of instruction. It's proof that resonance is the universal shortcut when you lack precision tools. A civilization with time would double down on that universality. Spherical harmonics don't care who you are. What nobody knew in the lab, not yet, was how soon a major window would lean toward Earth. The Analysts' drive carried a calendar flag in a tiny note. Prime lock series in 6 weeks, Earth-Jupiter geometry favorable. No exclamation marks, just a time. They pinned it to the corkboard and didn't tell anyone outside the room. Motive spectrum sharpened under that countdown. Maintenance reads as stewardship. Keep the dynamo quiet, route storms, buffer solar tantrums. Quarantine reads as boundary enforcement. Prevent resonance cascades that could destabilize or signal beyond the heliosphere. Beacon reads as coordination. Synchronize clocks across a network larger than our map. The same clock can serve all three, depending on who's listening. A retired archaeomathematician visited the lab one afternoon, coaxed there by curiosity and a promise of no cameras. He ran a finger down Mara's photocopy of the notebook and shook his head. Integer lattices for structure, primes for sequence, he said. We found that pattern in music long before we found it in machines. If you want a system to last, you make it simple to parse and hard to jam. He wasn't saying aliens tuned Jupiter. He was saying the logic scales. Deep time collapses when you realize the scaffold doesn't need constant attention. A prime protocol can run unattended for eons, adjusting to the sun's breath like a tree flexes to wind. If builders set it, their hands don't need to be on it now. If it's an ecology, it will act like any resilient system. Resist sudden change, prefer familiar rhythms, punish loud interventions. Mara's line landed late at night, when the room finally went quiet. We're renters, not owners. Nobody argued. The clock wasn't ours. We'd learned to hear it, not to command it. The calendar ticked closer. The coming window didn't feel abstract anymore. The lab cleared schedules, cut their network connections, and taped black paper over the office door glass. Motive would be inferred from behavior. And behavior would show itself when the prime hit, with Earth in the geometry. The countdown experiment. The plan looked simple on paper: listen, don't touch. Passive capture across the prime interval window, redundant sites, independent clocks, and no outbound signal. They called it the countdown experiment because the last week felt like living beside a fuse. Every conversation ended with a time. Every whiteboard sketch ended with a window. Redundancy meant 3 stations. The main dish on campus with the rebuilt front end. A rented mid-size array in the desert, run by a colleague who'd agreed to keep questions for later. And a quiet receiver far north near Auroral country. Old military surplus gear patched into new software, sitting in a Faraday cage inside a cabin that smelled like pine and dust. All 3 sites would run air-gapped logging, GPS disciplined, but with oven-controlled backup clocks and continuous spectrum dumps centered on the bands where the triplets had lived. They rehearsed the failure tree. If the campus dish lost power, the desert would carry. If the desert caught weather, the North Station would hold the pole. If the clocks drifted, they'd recalibrate with local pulsar beacons before and after. Everyone carried printed checklists, because if you're going to listen for a clock, you respect paper. The night arrived like a held breath. Hours early, the northern sky started to glow. Auroras bloomed ahead of schedule, soft curtains curling, then brightening in steps. It wasn't a storm, just a promise that the magnetosphere was awake. Down at the campus lab, the spectrum looked ordinary, broad hiss, ionospheric flutter at the edges. They ran the detectors at conservative thresholds to avoid false flags. A note taped to the rack said, "Observe." Don't lean. The window opened into quiet. Seconds ticked, then the first sign wasn't a spike, it was a narrowing. The noise floor thinned across a small band, as if someone had turned down a faucet. In the north, the Aurora dimmed, then a narrow arc brightened like a sharpened pencil line. At the desert site, a baseline jitter settled. No flags yet, just the roomful of bodies leaning toward screens without moving. The moment came without flourish. A triplet rose, each peak crisp, spacing locked to the prime rails within the tightest tolerance they'd ever recorded. Before Mara could name the intervals, the center line shifted a fraction of a bin, and the side peaks traded places. Phase shift. The algorithm hesitated, then flagged non-natural periodicity and phase anomaly together. The desert site called on a prepaid phone. We have a triplet with a crossphase. Same second. The northern cabin sent one line over text. Arc bright. 3 ticks. They let the recorder run. The triplet lasted 9 seconds, then the center tone pulsed twice, spacing compressed and recovered. A heartbeat. The campus dish had never seen that pattern. The desert site watched the same heartbeat under thinner noise. The north station caught the heartbeat in auroral brightness, 2 quick pulses, then a sustained glow. Impact landed with silence. Nobody cheered. They checked the locks on mics and transmitters. Everything stayed dark. If anything out there had acknowledged them, it didn't do it because they spoke. It did it because the clock said so. Still, the phase shift felt like a nod, a change in the way the triplet unfolded, as if a state flipped. The temptation to publish lit the room like static. A clean detection at 3 sites, an unusual phase behavior, auroral concurrence, and redundant clocks. But the stakes had been written on the whiteboard for weeks. Publish and risk suppression. Watch access narrow. Watch datasets vanish. Watch the conversation move behind glass. Hold and decode. Risk being scooped. Risk being mislabeled by louder mouths. Risk the window passing without a map. They took a vote and didn't announce the tally. We decode, Mara said, and it felt like releasing a held breath. Decoding meant dusting off the notebook's integer lattice and treating the phase shift as syntax, not glitch. The desert site shipped drives by courier. The North Station drove 6 hours to hand-deliver theirs because postal delays suddenly felt like sabotage. The campus copies went into a safe and onto 2 cold backups stashed at different addresses. In the hours after the window, small strangenesses stacked like cards. The campus magnetometer traced a soft reset signature, a quick deflection, a return to baseline, then a slower, cleaner ramp. Satellites reported minor telemetry burps that clustered near the window second, shrugged off as routine. The Aurora returned to its pre-window glow and held steady. The room filled with an odd mix of relief and dread. Relief because the machine hadn't screamed. Dread because something had answered its own schedule, and now they had to learn its language. Nobody said it out loud, but everyone felt it. If you hear a clock breathe, you've stepped into maintenance. They turned off the lights, left the fans humming, and started to translate. Decoding the phase shift. They didn't sleep. Drives cloned, clocks reconciled. They circled the whiteboard and wrote 4 symbols. 3 vertical bars for the triplet, a bent arrow for the phase flip. The notebook's margin had a hint. Phase is gate. If amplitude is volume, phase is timing, and timing tells you who can speak. They treated the center tone as carrier, the flanks as address pins. First pass was dumb on purpose. They quantized the intervals to the manuscript's integer rails, normalized by Jupiter's rotation, snapped to prime grids, measure offsets as small integers. The triplet sat at 2, 3, 5 steps, clean. Then the shift. The center slid by 1 unit, the side peaks swapped, landing on 3, 5, 7. The move wasn't noise, it was a progression. 2, 3, 5 to 3, 5, 7. Drop the 2, add the 7. A new shell engaged, an old one released. Maintenance handshake. They overlaid older radio ghosts from the Analysts drive and ran the same quantization. 2 sequences from the 90s showed the identical 235 to 357 flip, but in those nights the follow-on burst carried a faint 4th ridge at the 11-step distance, a tail the lab had never caught. They scanned their own capture at lower thresholds and found a whisper at the right bin. 1 frame above noise, 1 frame gone. Enough to mark, not to brag. Next came grammar. The manuscript scattered clues. Call open, act phase, work quiet, check tail. They built a minimal automaton, states as boxes, primes as edges. Call state, appear 2, 3, 5 triplet. Acknowledge, flip to 3, 5, 7. Work, A 9-second plateau with phase-stable carrier. Check. A brief 11-step tail or heartbeat. Their capture fit the march. Call AC work heartbeat. The desert site's second of compressed spacing read like punctuation. Comma, not period. Mara heard it before they coded it. She'd been looping the audio-converted spectrum at low speed, a habit she picked up when numbers blurred. The triplet sounded like 3 clicks, then a slightly lower, tighter chord, then a breath. That's a response, she said, and the room went still. Hearing pattern before proving it is dangerous. They wrote a rule on the board: belief waits for replication. Then they coded anyway. Cross-checks kept their hands honest. They fed the automaton Galileo cuts the analyst had tagged. Out of dozens, 3 sequences walked the same states with intolerance. Call, AC, work, heartbeat. One had a double work segment, 2 plateaus separated by a soft gap, like maintenance spanning more than one shell. Juno logs showed a cousin pattern, shorter but with the same phase flip. Different years, different instruments, same little language. They mapped nodes next. Assign each prime step to a harmonic family from the integer lattice. The manuscript listed L-bands paired with primes, 2 for deep torsional belts, 3 for mid-depth shear, 5 for upper jets, 7 for polar couplers, 11 for halo checks. Their capture toggled from 235 to 357, lifting activity upward and poleward, then ending with a faint 11. That's a functional map of hierarchy etched into timing, deep to mid to upper to polar to halo. The Aurora's behavior slotted in. During work, the oval brightened steadily, a sustained load. During the heartbeat, 2 sharp pulses marched across the arc, like current sheets pinched and released. The northern magnetometer's soft reset signature, a quick deflection, return, clean ramp, matched a system bringing circuits online, verifying, then handing back to idle. The grammar didn't need words, it needed sequence and consequence. They had both. They risked a synthesis and labeled the event. Maintenance check routed toward Earth's magnetosphere. Not a command, not a conversation, an internal service interval whose halo brushed our field enough to wrinkle instruments. The phase flip read as acknowledgement between layers, not between planets. Still, Earth sat in a coupling path that night, and the system touched us as it worked. They weren't done. A detail in the notebook nagged. Masking beats hide open valves, look for silence. In their capture, just before the call, the band narrowed, noise fell. They reprocessed older windows and found the same hush, a notch in the hiss, a preparatory quiet. The machine made room before it spoke. That became a new state in the grammar, pre-open. One more test, try to break the model. They randomized timestamps and spectral bins, injected synthetic triplets with near-prime spacing, and watched the automaton misclassify garbage as grammar only when spacing cheated within tight tolerances. When they widened tolerances, false positives bloomed. When they tightened to manuscript rails, the only sequences that survived were theirs and a handful from the analysts' ghosts. The grammar held shape under pressure. Maintenance of what? The lattice answered with a shrug you could translate. Momentum redistribution along allowed modes, magnetic load balancing through polar couplers, halo integrity checks at 11. You don't have to name every bolt to read the checklist. Call. Acknowledge. Do the work. Check. Breathe. The phase shift wasn't a glitch. It was a gate swinging on time. The Earthside echo. The decode said, maintenance routed toward Earth's magnetosphere. And once you say that out loud, you start checking our own house for footprints. We didn't look for spectacular, we looked for timing. If the halo brushed us during work, traces should cluster along predicted node times, small, bureaucratic anomalies that engineers shrug off and move past. Satellites blink first when space quietly changes. We pulled housekeeping logs from weatherbirds and comm platforms, public bits, nothing sensitive. Telemetry reported minor resets, and watchdog kicks clustered within a few minutes of the prime seconds. Not failures, self-corrections that cleared without operator action. You can chalk that up to solar noise. But during non-prime windows with comparable solar conditions, the clusters thinned. During prime, they fattened. It was a fingerprint built of shrugs. Power grids don't care about Jupiter, they care about phase. Yet operators file nuisance events when automated compensators trim the angle between voltage and current to keep turbines happy. We requested incident summaries from regions under auroral influence and got a handful of terse lines. Brief VAR correction, phase angle transient, no customer impact. Overlay the prime windows from the decode night and 2 earlier captures, and those corrections leaned into the predicted seconds. Not a blackout, just a nudge, as if the ionosphere's conductivity changed for a heartbeat and the grid did what it's designed to do, adapt. We wanted a cleaner room to listen in, so we looked north, where radio quiet zones try to hold the world at arm's length. Polar stations keep bands sterile for science. No phones, no FM, strict transmit bands. In those slices of enforced silence, a narrowband hiss occasionally rose inside the kilometric range, thin, slanted lines that shouldn't be there. The hiss appeared in a fraction of prime windows, drifted with local field lines, then faded. The lab's detector didn't call them triplets. It called them companions, possible side-channel artifacts of the same maintenance cycle brushing our polar caps. Hearing a whisper inside a library doesn't tell you who spoke, but it tells you someone walked the aisle. Human stories pin down abstractions. A pilot flying a magnetic survey route over subarctic tundra called in a compass spin, needle wandering 20 degrees, then snapping back. The timestamp kissed a prime second. He logged it as magnetic anomaly, added that his glass cockpit rode through fine, and forgot it by lunch. When we called weeks later, he laughed at the idea that Jupiter made his needle twitch, but he sent the raw. The spin started a beat before the window and settled 2 beats after. Maintenance breath can be a draft you barely feel, unless you're measuring north. There was more. HFHAM operators swapping notes about odd propagation during a quiet sun posted waterfall screenshots with faint, evenly spaced rungs appearing and vanishing in unison. We contacted 2 who log obsessively. Their clocks agreed within a second. Their locations were far apart. The rungs matched a window where our automaton marked work. They didn't claim anything. They just wrote, "Weird night." The stakes sharpened in a plain sentence on our board. If this is spillover, the system includes us. Not as a target, not as an add-on, but as a medium it crosses. Earth's magnetosphere is part of the same plasma cloth. When Jupiter routes load through the heliospheric field, we feel the tug in tiny ways. Satellite subsystems pausing, grids breathing, compasses twitching, polar hisses singing under the noise floor. That isn't spooky. It's a network doing network things. And yet the fear sat in the chairs after everyone left. What happens if maintenance stops? If the clock slips and stays slipped? The decode offered one dark model. Missed window followed by sloppy, low-Q bleed. Scale that to a system and you get messy currents, noisier auroras, jittery ionospheres, and hardware built for expectations suddenly meeting variance. You don't need catastrophe, you need drift. Our machines like rhythm. They assume yesterday's space will look like today's. A thermostat that holds the middle is invisible until it coughs. We'd earned a careful sentence, so we used it. The side echoes don't prove intention, they prove coupling. But coupling changes responsibility. Knowing when the window's open means we can test without touching, correlate without claiming, and prepare without panic. There was one more prime on the calendar, the last in the series flagged on the Analysts drive. One last window to see if the echo repeats, and if the maintenance breath reaches us again. The last window in the choice. The last window sat on the calendar like a loaded question. The Analysts drive had flagged it months earlier. Now it was hours away, and the lab wasn't a single lab anymore. Half the team argued to signal the node, send a passive timestamp, a 1-bit marker folded into the noise, nothing that could drive a mode, just a tick that said, "We're here." The other half clung to the whiteboard rule, listen only. Ethics took center stage. Touching a system you don't understand is arrogance in a lab and reckless in space. Even a passive tick could create phase perception if the schedule is sensitive to correlation. They called 3 quiet advisors, 1 plasma physicist, 1 comms engineer, 1 ethicist, and heard 3 versions of the same caution. Information is energy when a protocol listens. The lab drafted a compromise. No energy injection, no modulation, just a timestamp file written to disk exactly on the prime second, with no transmission hardware powered. A signal to themselves, not the machine. The hour approached. The desert site reported clear weather. The northern station sat under dim curtains. Campus gear hummed in a room that smelled like dust and ozone. 10 minutes out, magnetometers smoothed. 5 minutes out, a thin notch opened in the noise band, the same pre-open hush they'd marked during decode. Wrists buzzed with synchronized alarms. The clock rolled. They executed the decision. At T, computers at all 3 sites wrote a local timestamp file and nothing else. No antennas keyed. No ports opened. A private metronome click. The window opened and silence held. No triplet. No auroral flare. Spectra lay flat enough to pass for boredom. 30 seconds crawled. Someone muttered that they'd spooked it by deciding anything at all. Another counted primes under her breath, like a prayer she didn't believe in. Then the sky answered sideways. The Aurora didn't spike, it unfurled. A wide-field sheet broadened across the northern arc, ghost bright and even, like frost spreading on glass. The radio rose gently, not in 3 peaks, but in a single ridge wide enough to blur edges. The algorithm, built to love tidy triplets, hesitated and stayed dark. 9 seconds later, a soft reset signature traced across the campus magnetometer. Quick deflection, return, clean ramp. The desert site texted one sentence. Reset signature here too. The northern station added. Arc widened on schedule. Instruments caught what eyes and ears might miss. Belts in the vorticity stack eased for a handful of frames, then snapped back. A faint, slow oscillation in the decametric band rode over the ridge. Too slow to be a triplet, too regular to be none. The team's automaton, fed with the new capture, labeled it Maintenance Soft Reset. Not a call, not work. A system-wide breath that swept through without the punctuation of a checked tail. Relief mixed with dread in the room. Relief because no spikes meant no clear changes in the Lattices' shell addressing. No indication that the protocol had incorporated a new participant. Dread because the machine had done something different on the night they chose to do anything at all, even privately. Correlation isn't causation, they told each other, and still the question sat in the center of the table like a heavy object. Whether we touched it or it touched us. They pulled power from every outbound line, even the ones already dark, and let the last window pass into quiet. The Aurora thinned. The ridge faded. Magnetometers smoothed into the normal roughness of Earth's field. The desert sky cooled. The northern station brewed coffee and didn't talk. Aftermath lived in small signatures. Satellite housekeeping clustered again near the window second. 2 resets, 1 watchdog. Grid logs filed a minor phase correction that no one noticed until later. None of it proved a handshake. All of it sketched a silhouette of a system that includes us in its maintenance sweep, whether or not we intend to be included. They wrote 2 final lines on the whiteboard. First, no outbound until grammar expands. Second, document don't declare. No claims about intention. No press. Just a map of a choice made and a response observed. The meaning would have to wait until the protocol spoke in a voice they could translate without guesswork. For now, the lab held on to the simplest truth. They'd watched a window open, felt a soft reset wash through, and stepped back from the glass. Resolution and meaning. If Jupiter is a machine, we're living inside someone's infrastructure, and our lights flicker when its maintenance breathes. Want the decode breakdown and raw node maps? Subscribe and watch the follow-up where we release the packet structure and test side echoes during the next prime window. Hit subscribe so you don't miss the live capture. We'll run it during the window most likely to answer back.